Okay, guys, this class kick, you're going to have a test next Tuesday. All right? Your test is 14 questions, and it's going to say solve. It's not going to tell you how to do it or what to do. It's just going to say to solve. So you're going to need to know what to do in each situation. This weekend, I just recorded myself working all of the problems out last night from the test review. There's an additional test review that I will work out as well, and I will post that video. You guys should work these problems out, but not with the answers next to you. You should try to work them out on your own. See where you get stuck, then kind of look for some guidance. Monday, come in with questions on, I got stuck on this one. I don't know what to do here. But let's just go over this class kick. Just different variety of problems, talk through it. First thing, this is going to end up being a huge number, so let's just change this to a 3. All right, we're not going to have any ginormous numbers where you're multiplying and you're getting the hundreds of thousands or anything like that. I know on WebAssign the numbers can get big. Some of the graphing is difficult. We're not going to make your life miserable with that. All right, in this first question, how would we go about solving this? Tell me. Okay, we're going to raise it to the what power? 3 over 1. We're going to use that denominator. So I'm going to raise this. What you do to one side, you do to the other. So think about it. When you raise a power to a power, you multiply. So 2/3 times 3 over 1 is going to leave me with x minus 1 what? Squared equals, what's 3 to the 3rd power? 27. All right, now remember we talked about working smarter, not harder. We could write out x minus 1 times x minus 1. Multiply it out, move the 27 over, see if you can factor it, all that good stuff. But what's the quicker way to solve this? Take the square root of both sides. Good. When you take the square root of both sides, guys, what goes in front of your answer? Plus or minus. Perfect. Square root of 27. And then now what? It can break down. Good, but we're going to add 1 to both sides. So x equals 1 plus or minus. What does root 27 break down to? 3 square root of 3. Perfect. Much quicker than foiling and moving over and quadratic formula and all that stuff. If you have a binomial squared set equal to a number, just take the square root. Questions? Okay, I just want to go through different types of problems. Last period surprised me. They knew exactly what to do on this question. Yes, sir. All right. Don't tell me you factor out. We're not going to have a factoring out kind of problem where you have to factor out fractional exponents. We talked about that. In this situation, guys, what would be the best thing to do? Brianne, tell me. Substitution. What should I do with that 6? Let's subtract it. Let's move it over. So, guys, look, we have x minus 1, God bless you, to the 2/3, minus 5 times x minus 1 to the 1/3, minus 6 equals 0. I have 2/3, 1/3, 0/3. When we use substitution, remember we use let u equal, it's that middle term. What is u going to equal? X minus 1. Whoa. X minus 1 to the 1/3 power. Perfect. So now this just becomes u squared minus 5u minus 6 equals 0. Can I factor that? What are the factors of negative 6? That multiply to give me negative 6, but add to give me negative 5. U minus 6 and u plus 1 equals 0. All right. Now I can substitute back. What did my u equal? Okay, so I have, what's another way I can write x minus 1 to the 1/3? The cube root? Okay, so I'm just going to write it like that. So the cube root of x minus 1 minus 6 equals 0. And the cube root of x plus 1 minus 6. Why did I put plus? Hold on. Sorry. Minus 1 and then plus 1 equals 0. So on the left-hand side, how do I solve? I'm going to add 6. So the cube root of x minus 1 equals 6 and to the 3rd power. How do you undo a cube root? You cube it. What you do to one side, you do to the other. So I have x minus 1 equals, what's 6 cubed? 216. And then I do what to both sides? Add 1. So over here I get x equals 217. Same thing on the other one. What do I do to both sides? minus 1. Perfect. So I have the cube root of x minus 1 equals negative 1. Now what? You cube it. So x minus 1 equals, what's negative 1 times negative 1 times negative 1? Negative 1. And then what? Plus 1. Awesome, guys. So x equals 0. Wonderful. Wonderful. Yeah.
Do we have to check for substitution?
No. When we're going to check if it's a square root problem, we need to check if a rational has a variable in the denominator, and we need to check our absolute values. All right, let's look at this one. What shall I do? Just cube both sides. Perfect. What happens when you cube a cube root? It cancels. This just becomes a very basic linear equation. We have 2x minus 7 equals 7x plus 9. How do we solve? Subtract 7x, okay. And add 7. So negative 5x equals 16. And then what? Divide by negative 5. So x equals negative 16 over 5. Do we have to check that one? No. You don't really have to worry about the odd roots when you have the same thing on both sides, because it's just going to, it'll work out. Mostly the even ones. But in this case, since you have both things are underneath the radical, you know that they're equivalent since they're both. All right, look at the next one. Okay, pay attention to this one, guys. Pay attention, pay attention, pay attention. We've seen these on WebAssign. This is on the review. This will probably be on the test. All of these types of problems are going to be on your test. That's why we're going over them. How shall I go about solving this? The first step is always the hardest. Evelyn, tell me. Okay, good. We're going to move one of the radicals to the other side. I agree. I'm going to subtract the square root of x just because it's smaller. But you want to move one to one side, one to the other. So I have the square root of x minus 24 equals 2 minus the square root of x. Now that I have one on one side, one on the other, what can I do? You can square both sides. So when you square a square root on this side, it just becomes x minus 24. This is 2 minus the square root of x times 2 minus the square root of x. You cannot distribute that the exponent over a plus and minus sign. It's that binomial written 2 times. So you're going to FOIL. 2 times 2 is 4. 2 times negative root x is minus 2 square root of x. Negative square root of x times 2 is minus 2 square root of x. And then negative square root of x times negative square root of x is plus x. Perfect. So I still have my x minus 24 equals, I have 4 plus x minus 4 square root of x. Right, with me? All right, so now we're down to just one radical. That's what we wanted. So let's move the 4 and the x to the other side. So minus 4 minus x, minus 4 minus x. What happens to my x's on the left? They cancel. Negative 28, this is gone, equals negative 4 times the square root of x. Now what? Perfect. Divide by negative 4. So the square root of x equals 7. And then, so what does x equal? 49. So I'm so happy that I came out with a nice pretty answer of x equals 49. But guys, we're starting off right here with square roots. Anytime you have a radical that's a square root, you should just go back and check just to make sure. It takes 2 seconds. Let's plug this back in. I have the square root of 49 plus the square root of 49 minus 24. Does that equal 2? Well, what's the square root of 49? 7. What's 49 minus 24? Okay, and the square root of 25 is? Guys, does 7 plus 5 equal 2? No. So is 49 a valid solution? No. So what's my answer here? No solution. On your test on Tuesday, no solution is a possibility. You might get an answer and you plug it back in and it makes a denominator 0. No solution. You might plug it back in and it makes an absolute value equation untrue. No solution. You might have a case in an inequality where it's either no solution or all real numbers. So we need to pay attention to those things. All right, moving along. How do I go about solving a problem like this? Okay, I want everything on one side. This is a quadratic inequality. A quadratic inequality. So we're going to minus the 4 from both sides. I have 2x squared minus x minus 4 is less than or equal to 0. Once we have everything on one side and 0 on the other, you now treat this like an equation because you're just trying to find points, your key points. This sign tells us a lot. Excuse me. What does that sign tell me? It's an and. Good. Elijah, what'd you say? Closed circle. So where are we going to shade? In the middle. And what else does it tell me? Brackets. Wonderful. So now we just find little pieces, our key pieces that we're going to put on our number line. Figure out where we shade. Your answer needs to be written in interval notation. That's what I'm looking for. So, first thing we're going to try to do is factor. Does this? No. Okay, that's annoying. So what are my two options? Completing the square or quadratic formula. Since your B term is not even and your A term is not 1, I would just go with quadratic. So x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times A is 2 times C is negative 4 all over 2 times 2. All right, I'm going to say something. I want you guys to listen. On your test, when you're solving quadratics, you can get imaginary answers. But when you are solving an inequality, not an equation, an inequality, you should not get imaginaries. Because can you put an imaginary number on a number line? No. So an equation, yes, you can get I's, but you won't on your inequalities because then it wouldn't be true. So in this case here, if you guys got a negative underneath the radical, you need to go back and check your signs.
On the homework last night, there was like one question where like you were supposed to, like I got the answer right.
And then it was hard to graph
like,
it?
I couldn't graph
Yeah.
it because it was an imaginary.
Okay. Graphing on last night's homework with the quadratics was not fun. I understand that. The number line is difficult on WebAssign. Again, your test, I'm just looking for the interval notation. You use the key points in the graph to kind of gauge the interval notation. So don't worry about that. All right, so when we simplify here, I have 1, excuse me, plus or minus, what's negative 1 squared? 1. Then I have negative 4 times 2, negative 8 times negative 4. So positive 32 over 4. So x equals 1 plus or minus the square root of 33 over 4. Now, on a number line, do I need to know exactly where that is? No. But you do need to know, guys, where these points are in regards to 0. All right? So some of you are like, I don't know how to figure this out. Well, let's think about it. What is the square root of 33 close to? What perfect square? 36. Okay, so let's think about this. If I said 1 plus about 6 divided by 4, what's 1 plus 6? 7 divided by 4. Where is 7/4? To the right or the left of 0? Okay, so this is over here. 1 plus the square root of 33 over 4. So again, the square root of 33 is about 6, a little less. So 1 minus 6 over 4. What's 1 minus 6? Negative 5 over 4. Where is negative 5/4? To the left. All right? Why is that important, guys? Not because I need to know that you know where it is on a number line by the way it looks, but think about when we shade. You guys told me that we were going to shade where? In the middle. If you put both of these either on the left-hand side or the right-hand side of 0, you would not have shaded over 0. So when I shade here, I shade over 0, meaning 0 should what when I plug it into my inequality? It should work. It should make my inequality true. 0 squared times 2 is 0 minus 0. Is that less than or equal to 4? Yes. So that's why it's important. I don't need to know exactly in between 1 and 2 where it is, but you need to know where these points are in regards to 0. 1 is on the left and 1 is on the right. So when you write your interval notation, You now know that you're correct because 0 should be in between those two. So how do you write your interval notation? What's my answer? Bracket 1 minus the square root of 33 over 4, comma, 1 plus the square root of 33 over 4, bracket. Don't get hung up on because you had to use the quadratic formula. Everybody in here can do that. That might be the hardest type thing. It's not really that hard. You guys can handle it. All right, move along. Before we solve this, I want to talk about it for a minute. What is this? Absolute value, good. And it's an inequality. If this was an absolute value equation or an absolute value inequality, before you can figure out how to split it into two, what has to happen first? They have to isolate the absolute value. So we have to divide by 2. Guys, am I dividing by a negative number? No. So let's talk about this for a second. I'm going to do this problem here in a minute, but I want to talk for a second. Less than or equal to 2. Okay? So sidebar. Say this said x minus 5 is greater than or equal to negative 1. It says the absolute value. What do we know about absolute value? It's always what? Positive. It says the absolute value is greater than a negative number. When is that going to happen? Always. How do I say in interval notation this is always going to happen? Not all real numbers. Interval notation. Negative infinity to positive infinity. This will always be true, guys. Absolute value will always be greater than or equal. Always be greater than a negative number. What about if this said the absolute value of negative 5 is less than or equal to negative 1? This is never. So your answer here would be no solution. Understand those two things. You cannot make that statement, though, until your absolute value is completely by itself. So make sure you divide by whatever you need to, that sort of a thing. If we multiply or divide by a negative number, what do we do to the inequality sign? Flip it. If you multiply or divide by a negative number, what do we do to the inequality? Flip it. Okay, so let's go ahead and solve and then we're done. So I have two different inequalities. I have x minus 5 is less than or equal to 2. What does my other one say? X minus 5 is greater than or equal to negative 2. Perfect. In both cases, guys, what do we do to both sides? We're going to add 5. So here I have x is less than or equal to 7. And here I have x is greater than or equal to what? 3. Okay. So in regards to 0, where are 3 and 7? To the right. Good. 3 and 7. What kind of dots do I have? Close. Perfect. So my first inequality says all of the numbers that are less than or equal to 7. So that would be this direction, correct? My second inequality says all of the numbers that are greater than or equal to 3. So that'd be over here. So where is my solution set? Right here. Between those two. From where to where? 3 to 7. And I put it in brackets. Why is it in a bracket? Closed circle. Less than, greater than, or equal to. All of those little things you guys got to pay attention to. Once you find those key points, you've got to remember open circle, parentheses, closed circle, brackets. Less than, we shade in the middle. Greater, we shade where? On the outsides. Okay, so this weekend, I'm not saying right before you, as you're getting ready for the homecoming dance, you don't have to do this, but between now and Sunday night, you should work out the test review and the extra review. This video will be posted. The review video is already posted, and I'll work out the extra one and post that too. Okay, come to class Monday with questions.